Volume of a solid with cross-sections. Finding the volume with cross-sections is an important part of calculus. It makes use of integration knowledge, the fundamental theorem of calculus, and basic pre-calc knowledge of geometry and algebra. It can be used in architecture and in finding the volumes of three-dimensional figures. The steps. Number 1, you will need to identify the functions and/or the axes you will need. Number 2, determine the bounds you will use in the integral. Number 3, determine the equation that represents the distance between bounded values. Number 4, identify the correct area formula to use. And number 5, set up and solve the integral. The area equations you will use will be semicircle, pi r squared divided by 2, square, length times width, which equals chord squared, equilateral triangles, chord squared, square root 3 divided by 4, isosceles triangle with a leg as its base is 1/2 chord squared, and with a hypotenuse as a base is 1/4 chord squared. The first example, find the volume of the solid created by f of x equals x squared, x equals 3, the y-axis and the x-axis. The cross-sections perpendicular to the x-axis are semicircles. The bounds for the integral will be x equals 0 and x equals 3. The base of the solid will be the figure created by the bounds here. The 3D figure will be semicircles, which are infinite. The solution. Step 1. The functions used are f of x equals x squared, x equals 3, x equals 0, and y equals 0. Step 2. The bounds are x equals 0 and x equals 3. Step 3. The distance between them equals x squared minus the x-axis, which is x equals 0. Step 4. The area of a semicircle is pi chord squared divided by 2. Step 5. The integral will be set by the bounds 0 and 3, and the chord squared is x squared minus 0 dx. Step 5. The solution, which you can plug into your calculator, is the integral found in the previous section. The answer to this question is solved by the fundamental theorem of calculus, f of 3 minus f of 0. The answer is 76.341.
Example 2. Find the volume of the solid created by f of x equals sine of pi x and g of x equals x minus x squared in the first quadrant. The cross-sections are perpendicular to the x-axis and are squares. So that means that the figures that we are making are going to be in this set of boundaries. Solution. Step 1. The functions used are f of x equals sine of pi x and g of x equals x minus x squared in the first quadrant. Step 2. The bounds are x equals 0 and x equals 1. This is the work for finding the bounds. Step 3. Distance between equals sine of pi x minus x squared. Step 4. Area of the square equals side squared. Step 5. The volume is equal to the integral from 0 to 1 of sine of pi x minus x squared, all squared dx. We used our calculator to solve this integral, and we found that the volume is equal to 0.275.
All right, here's example 3. Find the volume of the solid created by y equals 5, the y-axis, and y equals absolute value of x in the first quadrant. The cross-sections are perpendicular to the y-axis and are equilateral triangles. So we have our function right here, and we're going to make this area the base, and we have triangle cross-sections. So it's going to be a triangular prism as our 3D figure. So here's our solution. Step 1, the functions used will be with respect to y, so we got to convert it into x equals something. So we got x equals the absolute value of y, and y equals 5, and then we also are bounded by the y-axis. So the bounds we found are y equals 0 and y equals 5, and then the distance will be the absolute value of y minus 0. So then we find the area of an equilateral triangle with respect to our function, and then we put that in our interval with respect to y, put that in your calculator, and you get 18.042, and that is volume of a solid with known cross sections.